Hey Internet, this is going to be part 1 of a 2-part tutorial on creating a directional weapon like the Metal Blade from Mega Man 2. The setup for this tutorial includes creating 3 new objects and 2 new sprites. The first object we're going to look at is our input object. After opening this object, we want to add a begin step event. This will guarantee that our input from our player is grabbed before the step event of any other object is run. We need to set our gamepad's dead zone, just in case our player has a twitchy joystick. It doesn't necessarily have to be 0.5. I've also seen other people set it at 0.3 or 0.2. Since we're not doing any pressure-based input, I prefer to set it higher. Even though our goal is to shoot our weapon in 8 different directions, we actually only need to capture the input for 4 directions. We'll start with the player pressing up. I'm going to call this variable move up because since we're checking for a key or button to be held down, we can also use this variable for the player movement later on. There are 3 ways we want to check to see if the player's pressing up. The first is the gamepad axis of the left joystick. The second is the up direction of their D-pad, and the third is if they're using keyboard controls. The code for the other 3 directions is exactly the same, with minor changes based on the direction we're pushing, so I'll go ahead and fill in the rest here for you to copy. The last thing we need to check for is if the player wants to attack. For this, we want to make sure we check if the button or key was pressed and not held down. For the purpose of this tutorial, we're going to use the left of the 4 face buttons and the space key to attack. This object doesn't have a sprite, so don't forget to put it in our room. We're going to skip over our player object for now. So let's open up our weapon object, assign it a sprite, and start with our step event. Just like our pendulum, all we're trying to do is adjust the X and Y position of our object. There are 2 key differences. The first is that instead of having a center position fixed, our center position will always be our current position of our object, so that we can continuously move. The second is that rather than defining a distance from a center, since our center is our object, we will define a speed at which we want our weapon to move at. We use the same length dir x and length dir y functions that we used with the pendulum. Now that we know what we want to calculate, let's go ahead and start defining those variables. For our speed, rather than pick a random number, we're going to set it based on the number of seconds we want it to take for our weapon object to travel across the room. We start with the width of our view and divide that by the number of seconds times our room speed. This isn't an object we'll be placing in a room, so we don't need it to be dynamic. This means we can set our speed locally in our step event. We'll use our point direction function again to get our angle. This time, since we don't want to be traveling in a circle, we want to be traveling in a straight line. Our first coordinates will be 0, 0. Our next pair of coordinates will be based on the direction that we want to travel. For this, we'll need 2 variables, an X direction and a Y direction. Since this object will actually be created by our player, based on the directions he or she is pressing, we don't need to set these here. Instead, they'll be set by the player object. However, we will be setting defaults later in the create event, just to prevent errors. There's only one thing left wrong with this code, and that's if the player has 0 input, the weapon object will actually stand still where it was created. So we just check to see if our X direction and Y direction are both equal to 0, and in that case, give it a default direction to travel in. We'll close our step event and open up a create event, and here we just set our default X direction and Y direction to 0, just in case we ever make any mistakes elsewhere in our code in the future. Now we're going to switch to our player object. Let's assign it a sprite and open up our step event. We set our X and Y directions based on the input the player has given us. All of our input variables can either be set to 1 or 0. Attacking in the left and up direction is considered to be attacking in the negative direction. Attacking in the right or down direction is considered to be attacking in the positive direction. This means that our input directions will always be equal to either -1, 0, or 1. This pair of X and Y inputs will allow us to attack in 8 different directions. The last thing we need to check for is if the player has hit the attack button, and then we create a weapon object. When we create our weapon object, we have to make sure we pass it our X direction and our Y direction. Otherwise, the weapon won't know what direction to move in. Unfortunately, I have a terrible memory. If I come back to this code a month from now and create another object that can also create weapons, I guarantee I'm going to forget to pass it in X direction and Y direction. The good news is I have a trick to share with you. We're going to create a script with the following name: create_O_weapon. The O is for object. This script will take two arguments, our X direction and our Y direction. This script will create the weapon object and then use the arguments we've given it to pass the object to the correct X direction and Y direction. If we annotate the top of the script as follows, and go back to our player object step event, after we type in the name of our script, the same annotations that appeared in the script also appear at the bottom of our screen. So the only thing we have to do is get in the habit of creating and using scripts for objects that require us to set variables when we create them. And that should be it. So let's run our project and see how we did. Our player can now shoot weapons in 8 different directions. In part 2, we'll add a spin to our blade weapon, and we'll talk about how to make sure everything's facing in the correct direction. Thank you for watching, and if you'd like to support Jumpman Gaming, please consider purchasing our game Sentinel Zero that is currently in early access and on sale, available on itch.io. If you have any ideas for future tutorials, please let me know. Thanks again for watching.